Now, coming to this video, let us discuss about the reactions of aryl halide. So here, aryl halide versus say alkyl halide. Please remember aryl halide and alkyl halide. Suppose say you have compound which is like this. Let's take the example of aryl halide, which is say chlorine. This is called chlorobenzene. Okay, let me be very specific. You have to form the bond properly here. Not teda meda. It should be straight line. And the length of the bonds in all these cases should be same. Okay. Now this is say chlorobenzene. This is called aryl halide. Aryl or aryl halide, whatever I say, aryl halide. And this is say alkyl halide. Okay. Alkyl halide. Now see, nucleophilic substitution faster in case of this alkyl halide compared to aryl halide. In other words, I can say like this: aryl halides are less reactive compared to alkyl halide towards the nucleophilic substitution reaction. So note this properly. I'll write here statement: aryl halides are less reactive compared to alkyl halide towards nucleophilic substitution or substitution reaction. So note all these points, yeah. Okay. Now why it is so? What is the reason? What is the reason? Why? Now the question is why aryl halides are less reactive compared to alkyl halide. Now remember one thing. In any reaction, if the bond can be broken very easily, then that reaction will be faster. So here, if you just compare carbon-chlorine bond, you have to break the carbon of the aryl group and chlorine. There's a bond. So this bond, if it can be broken very easily, then this reaction will be faster. But if you compare this with this, okay, here this carbon-chlorine bond is found to be very weak. I mean, not very weak, we can say is weaker compared to the carbon-chlorine bond over here. So please make a note that I have not said, I said actually very weak. It is not very weak. We can say with respect to the alkyl halide, carbon-chlorine bond is found to be weaker than the carbon-chlorine bond in aryl halide. Okay, you got it? So this why this bond is strong? Which one? Carbon-chlorine bond. Here in this case, this carbon is sp3 hybridized. So carbon, I will put it in short here, sp3 hybridized. Okay, I have said in words, so note that carbon in case of alkyl halide is found to be what? sp3 hybridized. Whereas here the carbon over here is sp2 hybridized. So I'll put it like this: carbon in aryl halide is sp2 hybridized. Okay, and because this is sp2 hybridized, this carbon-chlorine bond is found to be strong. Okay, note that properly, because that bond length becomes short here. When it is sp2 hybridized, the bond length between carbon and chlorine here and carbon and chlorine over here, I'll put it this way so that I'll just say it like this, just to compare. So carbon-chlorine bond in aryl halide is found to be shorter than carbon-chlorine bond in alkyl halide. Why? Because this is sp2 hybridized, whereas this is sp3 hybridized. And when the bond length is short, energy required to break the bond is more. And therefore, aryl halides are less reactive. So if you just can't get it, slow down the video and just hear my voice, what I am saying. So again I'll repeat. This carbon over here is sp2 hybridized. This carbon over here is sp3 hybridized. So when it is carbon is sp2 hybridized, always that bond between the carbon and the halogen is shorter. Whereas in case of this aryl halide, because this carbon is sp3 hybridized, this bond length between carbon and chlorine is bigger. When the bond length is short, energy required to break the bond is high. And because the energy required to break this bond is high, therefore this requires more energy and hence it is less reactive. So that is one point. So one point is what? Due to hybridization. Okay, now I'll just write in short here. I did not write a full thing here. So due to hybridization, carbon chlorine bond here is short. Which one? The aryl halide. In aryl halides, carbon to which halogen is bonded is sp2 hybridized. sp2 hybridized. And therefore the bond length is short. And because the bond length is short, energy required to break the bond, is more. Hence, aryl halides are less reactive. This is one reason. Okay. Second point, we can say due to resonance effect. Due to resonance. Now, what is that resonance? Resonative structures. Compound can be represented by different structures which differ with respect to the position of electron. Then that phenomenon is called resonance. So suppose I'll just show you here one. Suppose we have here chlorobenzene. I will show here the resonating structure of this. Okay. So here we have suppose say chlorine with a electron on this. Alright. Just to show how the bond shift here. Remember that one bond means two electron. One bond means two electron. So here in this case, of course, there will be electron here, that I need not show. Now this pair of electron can shift between this carbon and chlorine. Then these electrons which are there here between this carbon and this carbon, these electrons shift to the corner. Okay, see this, see where I am marking. They shift to the exactly at the carbon. And as a result, I can write another resonating structure which will be this way. Double bond will be created here with chlorine, and here there is a negative charge with double bond here and double bond. Okay. Then this electron can shift here. This electron can shift here. Okay, you can get another resonative structure. I will not show all the structures, but just to give you the idea, I am just explaining this. Here there will be electron, here there is electron, and this is double bond with chlorine. Of course, this will carry positive charge because I can show here two electron, can show two electron here shifting. Okay, that part I may not confuse here. So you can see this resonating structure, but in case of alkyl halide, which is say like this, CH3Cl, no resonating structures. No resonating structures possible. Okay. So when there is resonance, when there is resonating structure, there will be some more I can write. Say if you just shift here like this will go to this. Okay, if you want I can show that also. So here another resonating structure I can write so that you can know how the bonds are formed. And then this is electron here. and double bond as it is. Okay. So here there will be double bond. Now you can see, and then after that, of course, this will come back to this. This will go back to this here, and you can get your resonating structure, which will be this way. Double bond here, double bond here, double bond here with chlorine, and of course this electron will be reactive. Okay. Now, if you just see these resonating structures, when there are more, the compound is more stable. So, more the resonating structure, this is the statement, more the resonating structure, more is the stability. More is the stability. Therefore, aryl halides are more stable compared to alkyl halide. Aryl halides are more stable compared to what? Alkyl halide. And therefore, if you see alkyl halide, they are more reactive, whereas aryl halides are less reactive. So remember this. And one more thing, as I told you, I have shown here all the 6 electrons, 1, 2, 3, 4, 5, 6, 7, 8. So here there will be 2. So I have just shown the only one pair of electrons. Actually there are 3 pairs of electrons here. And as a result of this, what you can get here is positive charge. Here also there will be positive charge. Here there will be positive charge. And this is without charge, last. Okay. Anyhow, now what you can see here, why aryl halides are what? Less reactive. Just summarize first. I will just go fast. Why aryl halides are less reactive? One reason I have given, due to hybridization. The carbon in case of aryl halide is found to be sp2 hybridized, whereas carbon in case of aryl halide is found to be sp3 hybridized. sp3 carbon has a longer bond length between carbon and halogen, whereas here the bond length between carbon and halogen here is short. When the bond length is short, energy required to break the bond is what? High. And therefore to break this bond being high, this is found to be less reactive. That is one point. Second point is due to resonance. So these 2 points are remember. One more, this thing is reason is due to the phenyl cation which is produced. So there is one more reason, third reason, is due to the what? Formation of phenyl cation. That phenyl cation which is found to be more stable. Okay, and therefore instability of that phenyl cation. And as a result of that, the aryl halides are found to be less reactive. Okay. Now one more thing. This compound here, if you just see in these resonating structures, you can see that ortho position and para positions are rich in electron. Okay, just remember, ortho position and para positions are what? Rich in electron. Because they are rich in electron, therefore, if you just carry out the reaction here with the electrophile, as you know, there is nucleophile and that is what you call electrophiles. Nucleophiles are negatively charged, means carry more electron. Electrophiles do not carry electron and therefore they carry positive charge. So remember, this less of electron mean electrophile, more of electron mean nucleophile. So in simple way I am telling you. Now here therefore this position here is found to be rich in electron. Which position? Ortho and para position. Because they are rich in electron, if you carry out the electrophilic substitution over here, in case of aryl halide, then always you will get the 2 products, ortho and para. So electrophilic substitution in aryl halides results in the formation of 2 products. One is ortho and one is para. And para is more stable compared to ortho, which I will explain to you all in my next video. Okay. And one more thing, as I told you all, remember that in the difference in the reactivity, which I have explained to you all already about this difference in the reactivity of the aryl halide with respect to alkyl halide. Okay. So in my next video, I will explain to you all, as I just now said, about the thing that instability of what is called as phenyl cation. Of course, actually I should not explain again. Remember that what is that phenyl cation? Suppose after this is chlorine is removed from here, then that full thing will carry what charge? Positive. So it will be like this. When chlorine is removed from there, then this will carry what charge here? Positive charge. And that positively charged ion is called as phenyl cation. And because it is that phenyl cation is found to be unstable, therefore the reactivity of that aryl halides are less compared to alkyl halide. Okay, so in my next video I will explain to you about the this thing, what is the effect of the electrophilic substitution over here in the case of aryl halide. Always ortho and para. I think you must now keep it in mind why electrophilic substitution in aryl halides are found to be what? Ortho and para directing. The reason is this position in the resonating structure. Para position is rich in electron, ortho position is rich in electron. Therefore, electrophile being less electron, they carry positive charge, and therefore they will add to that place where there are more electrons. Okay. So next video I will explain to you.